This is Algebra 2 with trig. We're working in Unit 1. This section is called 1A.2. So we're going to talk about systems of equations. This has an absolute value in it. So we're going to graph this. We learned about graphing in the past. So a quick way to graph it without using RST is to look 1 to the left and 5 up. Follow the slope. The slope is -2. And then we need to do it with +2 slope the other way. And then 3, y equals 3 is this line. And that's y equals 3. We like to label our graph. And we can also label y equals -2, absolute value of x plus 1 plus 5. Always label your graph. So we're looking for the solutions of this intersection. Well, the solutions are where the two graphs cross. It crosses at 0, 3. And it also crosses at -2, 3. Those are the two solutions for the absolute value and a linear line that are crossing. They can cross 2 times. They can cross 1 time. Or they could cross 0 times. If it was not touching the V shape, it would not be crossing, would have no solutions if it was outside the V shape. Now that's one way we can solve this. We can use graphing. We can also do it algebraically. Here it talks a little bit about the algebraics. We would want to isolate the absolute value. And then we're going to break this into 2 equations. What's inside the absolute value could have been positive before we took the absolute value of it. Or what's inside the absolute value could have been negative before taking the absolute value of it. So we want to look at what makes the inside positive C and what makes the inside negative C. So first we need to isolate the absolute value. We'll divide by -2. So that's the absolute value of x plus 1 equals 1. Now remember, an absolute value has to always equal a positive number. Sometimes when we have other things going on around it, maybe it's going to say equal to a negative. But when you isolate it, like it is, once you take the absolute value of something, that of course has to be a positive. This seems reasonable because it equals a positive. We don't have any troubles yet. So we have it equal to 1, and we also have the inside of the absolute value equal to -1. Those are the 2 possible numbers that could have been inside that absolute value. So we subtract, and here we subtract again. And you notice that when the x value is 0, we get 3. And when the x value is -2, we also got 3. Those were the 2 solutions. This is the same exact equation we were working with before. We're looking to see where they're equal to each other. Those are our solutions. the solution of this equation would be x equals 2, x equals negative 2. When you graph it, you're looking for the solutions. That's when we're using ordered pairs. So here, first we're going to isolate our absolute value. And then that equals a positive, so we're okay. We'll take a 2x minus 9. That equals 15, just as it says. And 2x minus 9, that should equal negative 15. Those are the two options that could happen inside that absolute value. And we're going to solve to get the x by itself. And on this side, it's pretty similar but not exact. So we have our two answers. We have 12 and negative 3. You go ahead and try this one. If you're not ready for me to solve it, you could pause, finish up. I would need to multiply by 2 to have the denominators cross out. Then we get 16. Now, the absolute value equals a positive number. That's a good thing. It should. So now we're going to separate it to 4x plus 12 equals 16, and 4x plus 12 equals, what do you think? Negative 16. Divide by 4 to both sides, and x equals 1. So when we divide by 4, we get an answer of negative 7. So we have 1 and negative 7. So one thing that we can do, looking here at the gray box, remember you can always use your graphing calculator to verify your solution. Write the one equation as a system of two equations. The x-coordinate of the desired pair is your solution. So one thing we could do is go to y equals, type in our equation, and we're going to have 4x plus 12. We need to get outside of the absolute value, plus 3. Now we need to go to another equation, and we want to type that in as 11. When we graph it, you're going to see we have the absolute value, but I don't see the 11. But if you notice, your scale only goes up to 10, so that's why we can't see 11. So we need to take our windows to a y value maximum that is bigger than 10. So maybe 15 or 18 or 20. So you can now see that there's a lot more y values being shown. So let's cross it in 2 spots. So next we're going to say second trace. We go to number 5, which is the intersection of these 2 lines. Is that equation up here your first equation or one of the equations? The answer is yes, so you hit enter. Is that your second equation? Is that your second curve? The answer is yes. So now if you want the answer that's closer to here, we need to hit enter closer to it than we are to the other. You need the cursor to be moved. And notice what we got. We got 1 and 11. 11 was the answer. And we got the answer of 1, just like we did when we solved it algebraically. We could also go to second trace, down to 5, which is intersect. Hit enter. Scroll over a little bit so you can kind of see where that cursor's at. Is that the first curve? Is that the equation that you want to be on? Answer is yes. Move it over. So that's the equation that the calculator is going to use. Now, if I was to hit enter, it would go to the closest intersection. So I need to move it over so it is closest to this intersection. And they tell me -7, 11. -7 is exactly what we calculated earlier. So that checks out perfect. 1 and -7. On the flip side, we're going to solve absolute value, but this time you see that it equals an expression. When it equals an expression, multiple things can end up getting in the way. And one of the things is called extraneous solutions. That means we're going to do the math perfectly right, but when we solve it, we may be getting an answer that doesn't even work in the original problem. So we'll try this out. We're going to solve it the same way to begin with. So we take our 15 plus m, and we equal that to the -2m plus 3. Now we're also going to take the 15 plus m, and we're going to equal that to the opposite of -2m plus 3. Notice that we can't just remove the negative. You have to put the negative in front. 2 negatives make a positive, true, but we also have to distribute it over here to the 3. So we'll go through and just solve the problem. So we get 3m. We'll subtract the 15. That's -12. We got the answer of -4. Now we're going to check that -4. We have to check for extraneous solutions. A lot of times we get nervous about having a negative answer. Let's see if that works out in our favor here. We're going to check this by plugging it into the absolute value of the original equation. The original absolute value. So that is the absolute value of 15 minus 4, 15 plus a -4, which is 11. Absolute value 11 still. And this is 8 plus 3. Negative 2 times negative 4 is positive 8. The absolute value of 11 is 11. And 8 and 3 is 11. So check, that worked. So that means that negative 4 is definitely one of the solutions. On this side, we would need to distribute that negative. Collector-like terms. So we distributed our negative through. We got a minus 3. I collected my like terms. So I still have the negative 3 there. I'm going to bring the 3 over to get 18 equals negative 2m. Divide by the negative 2. So m is going to equal negative 9. Let's see, did I type in my numbers correctly? What have I done here? So I have my 15 plus m, and my 2m minus 3. Oh, I only subtracted the 1m. Oh, look at that. Sorry about that. 2m minus 1m is just 1m. So there is no more dividing. Sorry about that. Knew something looked a little funny. So the m value equals 18. That's the question. Is that really true? So we're going to do a check. And when we take the 15, which is in absolute value bar, equals, or 15 plus 18, because that's our m value, equals negative 2 times 18 plus 3. This adds up to 33 in the absolute value bar. This adds up to negative 36 plus 3. So this is 33 equals negative 33. They do not equal. So this one here is called an extraneous solution. So we put an X through that answer. We don't erase it, we don't ignore it, we need to say that that answer is extraneous. We could check our answer by bringing over our graphing calculator, typing in our equation, the absolute value of x plus, now we can't do an m, whoops, sorry, 15. We can't do an m, 15 plus m. We can do 15 plus x. That's the best we can do in a graphing calculator. And then our next equation is actually negative 2. We can't do m again, so we're going to do x. The variable doesn't matter. The calculator always shows the x. So we're going to graph this. Now that's kind of a funny looking situation. I didn't know we had two lines being graphed. I thought we had a vertex being graphed, an absolute value being graphed. If I look up here at my original absolute value, this would be, the h value would be your 15. And since the 15 is a positive number, this must be moving 15 to the left. So if you really wanted to see the whole graph, I'd go to Window, down to my minimum x, and we're going to make that larger than negative 15, or actually smaller than negative 15. So I'll pick negative 20. So there you get to see the actual absolute value, and this would be the linear line of negative 2m plus 3. It crosses at 3 and has a slope of negative 2. This has a vertex at negative 15, 0 and opens up with a slope of 1. So this is where they're crossing. So to figure out exactly using the calculator where they cross, we're going to say second. Hit your second button. And then hit the trace button or calc. And you come to this new screen. We're looking for number 5. We're looking for the intersection of where these two graphs meet. So scroll down or just hit the number 5. And it's going to ask you, is this your first curve? And you hit enter to say yes. Is this the equation of your second curve? You hit enter to say yes. Then it says guess. You've got to get the cursor next to the solution you're looking for, where these two only cross at one spot, so it really doesn't matter where you hit it. But I get a little closer for fun. Then hit enter, and you can see it's negative 4, 11. Negative 4 gave me the 11 as an answer. So that worked out great. So here we got negative 4, 11. And that is when our graph that looked something like this this solution right here was negative 4 over and 11 up. Let's try it again. You go ahead, you can pause the video, go through and solve this, and in a moment I'll start up mine and you can watch it after you're done. So pause the video, start it again when you're done. So we're going to take the 4x plus 10 in absolute value. Well, mistake number 1. We don't need the absolute value signs if we're going to start to solve this. We're going to write it as a positive 6. We're going to take the 4x plus 10 and write it as a negative 6x. So we begin to solve it. We get 2x. So x equals 5. We can check that. So when we plug in the 4 times 5 plus 10 into 6 times 5, we're going to get 20 plus 10 is 30. Absolute value of 30 is 30. We got 30 again. So that worked out just fine. On this side, we can subtract our 4x if you want to bring your x's together. So our x value equals negative 1. And when we check that, we're going to get 4 times negative 1 plus 10 inside the absolute value bar. That equals 6 times negative 1. This is negative 4 plus 10 equals negative 6. This is 6. Does 6 equal negative 6? And the answer is no. So this would be considered an extraneous solution. So we put an X over that answer and we only circle this one. We can check this in our calculator. So we'll type in the absolute value of 4x plus 10. Then go down to 6x. See where those two graphs cross. Notice that they're not crossing on this line at all. They do cross up a little higher. They're crossing up maybe when x is 30. We see that over here. So I'm going to pick a window where my maximum y value is bigger than 30. We'll go way up to 50. There it does. It crosses. You can hit second calc, second trace. Come down to number 5. Is that the equation of your first curve? Hit enter. Is that the equation of your second curve? Hit enter. Then you want to get close to the solution. We hit enter, and you notice that's 5, 30. And when you look here, that's exactly what we got, 5 and 30. It crosses at no other location. So that's why we have an extraneous solution, because it doesn't cross a second time. We can come to our next one. It says verify your answer using your graphing calculator. So we'll first do it algebraically. We have to use parentheses around that. So we add the 1. Subtract the 2x. And we're going to get x equals 5. Now we can check this to see if x equals 5 makes sense. So we say check. We use the absolute value. So that's 20 minus 1 is 19. And 10, 2 times 5 is 10. Plus 9 more is 19. That worked out great. That is the solution. We'll distribute our negative through. Add the 2x. Add the 1 to the other side. We got negative 4/3. So as we are going to check this one out, we'll plug it into the original problem. Here we get 16 divided by 3. Negative 16 divided by 3 plus 10. That looks scary. This crosses out a little bit. You get 2 times negative 4, which is negative 8. So this is going to become negative 16 thirds plus 30 thirds. So when you take negative 16 away from 30, we get 24 thirds equals negative 8. Well, 24 thirds, that's 8. Look at that. Got really close, but one's a positive and one's a negative. That's not equal. So that means that this is not an answer. It's called an extraneous solution. And we can do one more. Why don't you go ahead and start this one? You can pause the video until you're done. Turn it on, run it, see what you think. So we'll start with exactly the way it's written. Now here they have absolute value bars. I'm just going to put in parentheses because we have the A value on the outside. So I need to subtract the 5. Okay, I'm going to change my thought here. Don't we have to isolate the absolute value first? So to isolate the absolute value, we need to have an absolute value. My bad. So negative 4 divided by 2. So now we've isolated the absolute value. But something looks funny. Can an absolute value equal a negative number? The quick answer is no. It cannot equal a negative number. If you break this apart into two problems, you'll get answers. But those answers aren't working. They'll probably both come out extraneous. This does not work. So what this means is no real solution. And we know that because an absolute value cannot end up equaling a negative value. Just the absolute value. Once you isolate that absolute value, it's not allowed to equal a negative number. Up here could have. This could have been a negative number. Maybe these would have turned it positive by the time I isolated it. But by the time you get it isolated, it can no longer equal a negative number. No solution. Let's see what the graph looks like for that. So we'll get our graphing calculator and we'll type in our 5 plus 2 absolute value of x minus 4, and we'll graph the value 1. Now when I graph this, you notice the grid's kind of funny. It's probably good enough for us to tell what's happening. But if you hit zoom number 6, 6 is Z standard, it'll turn it back into the normal 10 by 10. And we can still see just why it's no real solution. They don't cross anywhere. No real solution if the two graphs don't cross. So that makes sense. That was checked with your calculator. Let's also come up here and check this one out. We can say absolute value of 4x minus 1. Clear that one out, clear that one out. And we're going to type in 2x plus 9. So it looks like it's crossing here. It looks like it's going to probably cross up higher. So let's go look up higher. Y value of a maximum. Look up a long way. It does. It crosses twice. When I came over here and looked at my solutions, it looked like it crossed at 5. And when it crossed at 5, I was at 19. Let's do that again. Second trace, intersection. Is that your first equation? Yes. Is that my second equation? Yes. Is that near my solution? Yep. 5 and 19 worked out great. Now it also says it's going to cross down here. That's interesting. I did not get that. Is that my first equation? Yes. Is that my second one? Yep. Is that near my solution? Yep. So I should have gotten an answer for this one. Let's come up and see where I may have made a mistake. We had the 4x plus 10 equals negative 6. Subtracted that to get negative 10, divided by the negative 10 to get negative 1. And that's not the problem we're working with. We're down here. So 4x minus 1 equals the opposite of that. So we distribute it. We added the 1 to get negative 8. We added the 2x to get 6. I don't see a difference here. Alright, I just noticed over here that I said that 30 minus 16 was 24. 30 minus 16 is 14. So 3 goes into that. 5 times would be 15, so it's not 5 times, it's 4 times, which is 12. It goes in there 4 times with 2 left over. But this would have been 24 1/3. I found it. It's not 10, it's 1. That's a 1 here. So that's a 1. So we have to get 3/3 here. So that makes that negative 13. And that's going to go in there a negative 4 1/3. And on this side, this side is still going to be 8. This is a minus sign. Wow. Oh, you see, I pulled my number from the wrong spot. That's what happened. Why didn't any of you tell me? You probably were. Okay, so you have negative 16 over 3. Minus that is negative 19. Which ends up being negative 6 1/3. And this side, because again, I pulled it from the wrong equation. I'm in this problem. It's 2 times negative 4/3 plus 9. So this is negative 8/3 plus 27/3. That's a value of 9. We're going to minus the 7 to get to 20, but minus the 8 to get to 19. Oh my goodness, it worked. There it is. That is a real answer. I take that back. It's not extraneous. And that's what a graphing calculator verified, right? Wow, I like graphing calculators. So x equals negative 4/3. That is a real answer. So in this case, we got 2 answers to work. Just keep checking your work. Don't give up. I noticed that I pulled half the equation off the wrong problem. If I could start over, I would, but I got the answer. That's what matters. Good luck.